Hello, today we're going to have an introduction to inequalities. First, this is split up into 4 sections: graphing, writing, testing, and then writing them from written statements. So the first part, we need to know symbols. Greater than symbol always opens to the left. Less than symbol opens to the right. Greater than or equal to has that little line underneath it. Same with less than or equal to. They have symbols when you graph them. If you have greater than or less than, you use an open circle. If you have greater than or equal to or less than or equal to, you use a closed circle. And we'll talk about that more in a minute. So let's say we're going to graph these 2 equations, inequalities. First, start with where the number is. So in this case, it's 15. It says n is less than 15. Well, points left, it goes left. That was one thing that young teachers or teachers of younger kids usually told. But really, if this symbol ever points to the variable, then you go left. If it ever, as they used to say, eat the variable, it goes right. So in this case, it's pointing at the variable, it goes left. In this one, it says negative 12 is less than or equal to n. Well, start with negative 12. It's a closed-in circle, meaning it's filled in. And then notice, even though this thing is pointing left, it is not pointing at the variable. Since it's eating the variable, we go right. How do you write inequalities from a graph? Well, let's go the other way. In this case, it says negative 6 is my uppermost limit, and it's filled in, so it has to be equal to. And everything below it works, so everything smaller works. So therefore, n, whatever your number is, has to be smaller than negative 6, or it could be equal to. On this one, n could be bigger than 13, but it's not filled in, so it can't be equal to. Notice that's not there. Look at those carefully. Now, how do you test an inequality? Well, if you put in n equals 5, does this make it true? Yes, because 3 times 5 is greater than negative 7. True. If I put in negative 3, though, 3 times negative 3 is negative 9. Is negative 9 bigger than negative 7? Not at all. Therefore, false. Negative 7/3. This one's interesting. If you put that in there, negative 7 times 3 is negative 21. Divide by 3 is negative 7 again. Is negative 7 bigger than negative 7? Nope. So it's false. On this side, there could be decimals. There might be fractions. If I put in 3, 3 minus 2.8 is 0.2. Is 0.2 less than or equal to 5? Yes. If I put in 9.2, 9.2 minus 8 is 6.8. Is 6.8 less than or equal to 5? Nope. So it's false. Now 7.8. 7.8 minus 2.8 is 5 exactly. Is 5 less than or equal to 5? It is. The answer is true. Now what about writing them from written statements? If I say the distance to Philadelphia is less than 100 miles, the distance could be 5 miles. The distance could be 20, but it couldn't be exactly 100, and it couldn't be like 110. Therefore, D, the distance, has to be less than 100. And that's all you have to write. If the stadium added 1,000 seats, and now the stadium has at least 5,400 seats, if it's at least 5,400, it could be exactly 5,400. Or it could be bigger than 5,400. So I start with the stadium. I'm going to call the stadium S. I add 1,000, so that's going to be S plus 1,000. And then it could be bigger than 5,400, or it could be the same amount, therefore greater than or equal to 5,400. That's all for today. Go back and look at these problems. Thanks as always for using Seyer Mathematics.